So welcome to Rancher GitOps on Kubernetes. I'm Mario Mano. I'm tech lead of the fleet team at SUSE. And I'm going to talk a little bit about GitOps and continuous delivery in Rancher, how we made it work in fleet, and some upcoming features. So GitOps in general, right? You have all these containers and you want them neat and tidy, orderly on a ship. So why would you do GitOps, right? For example, you need to deploy monitoring in multiple regions, and you need to have like special configuration per region, right? So then you could use that. Are you a platform operator? You want to provision clusters in a scalable and safe way, like everything should be auditable and readable. Or you're just trying to push your application and you want your latest changes to automatically roll out to your cluster environment. Or maybe you have like a Rancher extension or something and you want to just distribute a YAML manifest like in an easy way to all the clusters. So the principles, right, of the GitOps movement is that it's like a declarative approach. Everything is in Git, everything is in manifests. Since it's in Git, you get like you get a fixed version. It's immutable, so you can like rely on it and version it. It's being pulled automatically from the repository, and every time a change comes in, it's continuously reconciled. So what you do is like you have the desired state, the state of that. You have that in Git, and then you try to reconcile your cluster environment until the actual environment matches the desired state environment. Short disclaimer here, right? This is not a replacement for DevOps. Having a GitOps tool will not like solve all your platform needs. You won't be able to get rid of platform engineering. It's not a replacement for all of your CI and CD problems, right? So this is fleet and Rancher that's called continuous delivery. The problem we have like is most customers have like now more than 10 clusters. You might split them up into prod, dev, and test clusters, or maybe you have one cluster per location, right? Each, factory, car, or whatever is a cluster nowadays. So you have actually lots of them. You have 1,000 clusters in retail, right, in Edge. So with the continuous delivery, you can like provision clusters, like help with the provisioning of clusters, right? Not provisioning the clusters directly, but you can like deploy like low-level tooling and configuration to your clusters. You can like provide them with authentication and RBAC rules, or just like if you have like your own applications, right, from the development departments, you can distribute them to clusters or existing applications, right, like Cert Manager or something. Monitoring and logging is, I think, one of the first things people want to roll out, and you can like do that with continuous delivery. Talking about fleet and specifically, right? Like, let me see. Yeah, you can see the cursor. Right? You could approach the cluster and use kubectl directly, but the GitOps approach is going to pull the changes from this GitHub repository up here, and fleet will create like this bundle definition of what it finds in the repository. So it actually, for one repository, it might create multiple bundles, and then we have like a network of agents at the bottom. These run on the clusters, and all the clusters, we can put them in cluster groups so that you have some overview or some logical structure of your clusters. And these agents will pull the changes here from this bundle definition and will make sure that it's reconciled on the downstream clusters. They also report back the status, like is it modified, is the bundle out of sync, and so on. This is the first demo, right? I'm just going to show how Fleet works in general. These were embedded in the presentation in the beginning, right? But so we are looking at Rancher Prime. It's a 2.8 version, and I'm running this on my local machine. I created like 10 clusters with K3s. Right, so we're back to adding repositories. Well, yeah, entering the URL again. This is the part where I was going to say, like, if you want to access the GitHub repository that needs credentials, you could use that. Or this part here is the Helm authentication. So if your repository has wants to download Helm shards, then yeah, that would be where you could add a secret to download Helm shards with. But pretty standard stuff. And now we're taking a brief look at what I'm deploying. It's a simple fleet YAML. So I'm deploying the ngrok ingress here, right? Because my fleet cluster, it has like 10 small clusters, and I don't have a public IP address, but I want to make a service available, right? So this is a simple fleet YAML, right? If you ignore everything from down here, right? The diff is not really necessary. It's just a small conflict in labels. But what we are really doing is, like, we are telling Fleet to download a Helm release, like the ngrok ingress controller, and then we are telling it to get the values from a secret, because you need an API key to authenticate. So that is the whole content of the Git repo. So values from is like the secure way to provide values to your charts. And when we go on, yeah, that is like a diff to ignore the modification state of the resources. And we now click on create in the UI, or on next, we need to select like a cluster to deploy to. There are a lot of clusters which we could select by name, and the UI would do the right thing. You might be tempted to do a more complicated matcher here in the YAML view. There's like a cluster name matcher you could use, but this will match the this has to match the fleet cluster names, which are random. So don't do that. It's much safer to use like cluster labels instead. So we're going to create a cluster group just for the ngrok deployment. Going to the cluster group view here. And going to right, these have labels over there, the clusters, and we are going to create a new one, call it ngrok, and we're going to add a label here. Oh no, that's the wrong field. We are not going to add it here. We need to add a cluster selector, not a label on the cluster group, right? So let's click the right button over there. Yes, this one, and that is like ngrok. It just needs to be set, right? We don't care about the value. As long as the cluster has the ngrok label, it will be part of the cluster group. And now it's empty. We see like 0 clusters ready, so we also need to add the clusters here. So yeah, just going there, config, add label. All right. So that is like, I guess no surprise, you just put ngrok. I decided to put true, but the existence is enough of the label. Are we doing the same for demo 22? These are the 2 classes I'm going to show here in this, well, for the ngrok ingress. And the cluster group has 2 members. At that point, we can go back to the first part and can just say like, deploy to the cluster group. I could have clicked that in the UI, right, which would have been much better. But then I would have to reload the page because the cluster group was just created. And then it's going to deploy the ngrok ingress onto those 2 clusters. Luckily, it's a rather small shard, so we don't have to wait long. You can see that Fleet reports the status here. It's not ready. And Yeah, then it is green. And yeah, I think this is like the most basic way on how to use the continuous delivery part here. This is just proving that the workload was actually rolled out to the cluster. We can see the pod here in the cluster view, ngrok ingress is running. So so next, like we want to customize a deployment per cluster, right? Because now we just deployed the same ingress to both clusters. I did have to create the values file first manually. I didn't show that, right? The values file needs to be on the downstream cluster. But for other values, we can make use of customization. For example, if we want to change the namespace, something is deployed to the Helm values it uses. If you want to keep resources when removing the chart, right? Some charts are maybe a little bit dangerous to remove. If you think of Longhorn or something, you don't want to remove the CIDs. It might then remove the physical volumes. So this is like meant as a safety net against that. We also support customize as a post renderer, or if you have like exceptions to drift detection, or you want to turn on drift correction only for some charts, right? So this is then the next demo where we are going to take a look at sharding. That is something we do later, so can't play the audio. There is no audio on this file. Okay, so we go back. We are still on Rancher Prime, so this is the released feature we are looking at. We go back here. The ngrok ingress is still running on the cluster, and we're going to deploy a small static example, like a HTML site, just to show off the ingress here. Again, like where do we pull the changes from, and the right branch for that. We need to add like a subpath, right? I don't want to deploy the whole repo. You could do that with Fleet, and then we'll follow some rules to deploy like all the folders or subfolders or something. Well, anyhow, this is the Fleet YAML we are using this time. So this is like a templated value we pass off to Helm. So this is not really target customization, but this looks at the cluster labels, uses one of the Helm template functions, or similar to the Helm template functions, to make it uppercase. And then these here at the bottom are the actual target customizations, where we have a matcher here. In this case, we match a cluster label to get to the name. And then we set a value here for the ingress, and this is the host name we are setting. One gets cluster 1, and the other one gets cluster 2 as a host name. Down there in line, I don't know, 22, 21. And the chart itself is now embedded in the Git repository, so we are not downloading it from an external source like we did before. These are just the default values, and it's a simple Nginx deployment. We are using the SLE 15 Nginx here from registry.suse.com. So I was basically mounting two files over, and that is the config and the htdocs. Just for being like complete, right? There they are. Also going to show them they are stored in a config map. Just some HTML and some CSS on top. It's going to show the cluster env value, right, which is looking at the actual cluster, and it's also showing the ingress host where we are using target customization to override it. Yeah, and the ngrok ingress itself, it just needs the type ngrok. This is straight from the documentation of ngrok, so nothing special here. Just some YAML we want to put in a Helm chart. Yeah, again, like these two values. So we can go on and click next, and this time we are going to use the UI to select the new ngrok cluster group we created earlier. And yeah, this should deploy really fast because it's a small chart, doesn't need much, right? And we can see here that the status is reported back onto the cluster group view. And yeah, two are ready already. That is nice. It's green. So we can go and visit the sites next. And right, this is how it looks when it doesn't work, and we reload, and we can see our cluster label shows up, and the right Ingress hostname shows up, and the same is true for the second one. I really like this because normally it's hard to get stuff off my development machine into the internet, into a real public address. So that was a really good surprise. Very nice. Yeah. And here we can look at the resources. This is the config map. This is now on the downstream cluster. So the templating has been done. It has been deployed by the fleet agent. So it's right. It's all there. Am I showing anything more here? Yeah. The label. Oh yeah, right. If I remove the label from the cluster, right, it's no longer part of the cluster group, and then continuous delivery will take care of uninstalling it, right? And you can see here the count is now 1 of 1, kind of what you would expect. Going back here to the slides. Another feature we added is drift correction. That was something that was missing. So up to now, we've been very straightforward, right? We didn't really make use of GitOps, right? It was more like continuous delivery. We put something somewhere and then we deployed it. But I talked about continuous reconciliation before, and with drift correction, right, we can also correct problems on the downstream cluster. So I'm adding another example. Like basically, I want something on all the downstream clusters. It's like just the config map that I'm going to deploy here to show off this feature. Right, again, let's click next. Yeah, and just create it. And this goes out to all clusters. I didn't select a specific cluster group, so it's going to, this config map is now on all 10 clusters. And right, if you look at it, it has a few values. That value is directly from the Helm chart, like a default value. Then we have some fixed value that's in the YAML manifest of the config map resource, and we have a value that fleet overrides, I think, from the fleet YAML. So now what happens if I go to Git, right? I go there and I change it, right? This is like probably an audited change, something that you thought about. You put in a new value here, right? It might be something meaningful like a host name or so, but and you would maybe create a pull request and review it and whatnot. But in this case, we are just straight committing to the branch, like in a development or test workflow, and we can see that it rolls out. It's updating from Git now, and the updated value will be visible on the downstream clusters. So right, I'm reloading here. So there it is, the new config value that needs to be audited. But what happens if you go to one of the clusters here and change it manually, right? Like then at that point, like fleet should detect the drift between the desired state in the Git repo and the actual state in the cluster. So I'm going here. There's the important value. I think I'm on demo 26 currently. I'm overriding it. Maybe I'm stressed out, right? I need to fix something fast in the downstream cluster, so I'm overriding this and saving this. Yeah, and there it is. Value is overridden. I go back to fleet, and fleet shows me, well, you modified something. I go there, and it tells me, well, cluster 26 has a different config map. So at that point, we might decide, like, this is no good, right? We don't want people to manually edit stuff, so we go into the definition and we enable self-healing, like what I call drift correction. So when we turn this on, Fleet will detect the change, and the downstream agent will look at the latest deployed version and revert to that. So that just happened. And when we look at the config value, we see that it switched back to the one from the Git repo.
And now it's just the self-healing flag?
Yeah, it's self-healing flag, yeah. And if I try to overwrite it now, right, I really want to change it on 26. I was too slow, right? It already corrected it. So if I go back and try to show the value again, like you will see, like it did save, right? But then it reverted back like immediately. Yeah, config maps are really fast resources, so that's why that happens. So yeah, I think this is like the most of the basic functionality we have in Fleet. So I promised to talk a little bit about how it works. So at the top, we have the desired state that is in Git, right? And you just have your Git repository. There's a Fleet YAML, which is like a special documented format, but it's optional. In simple cases, it's really optional. If you have a big Git repo with a lot of subfolders, I would always recommend to add Fleet YAMLs there to control release names, namespaces, and so on. And then you have your charts and manifests or references to external Helm charts or whatever. So, and then one component of Fleet is like this GitOps monitor. This is like the next one down there. And it's going to, better not touch anything. It's going to see if the repo changes, and it's doing the clone. And if it finds like references to Helm charts, it will download them. Then we have a component that is like a multi-cluster manager that decides like which chart goes to which cluster. Are there special values here? Do we need to do templating? And finally, we at the bottom on the downstream clusters, we have the agents that just pull in the changes when they are online and apply the Helm install to get the chart onto the downstream cluster, and also do the drift correction part by monitoring all the resources that were deployed. I think the fun part is to talk about upcoming features. One thing that makes me happy is that, from the very old versions, right, like from 0.8, which I think is Rancher 2.7, we were able to not only reduce the image size, but also ship less images. And what really makes me happy is that here that we managed to get the Fleet agent to a smaller size, because that is the image that is loaded to all the downstream clusters. The main image here, the Rancher Fleet image, it grew a little bit in size, but that's because we consolidated the Git job controllers into the same image. So now we have to deal with less version numbers, and makes releasing faster and easier. And yeah, it also reduces the amount of images you have to download. So two new things we are adding. First one definitely is sharding. So Fleet wants to scale to, we do have users with more than 1,000 clusters in Fleet, but ideally we want to scale more. I think originally, like the vision was to scale even bigger, but there are certain limits in how many resources you can create. Sharding is one way to scale horizontally. We just spawn more pods, right? And you will be able to assign them to certain nodes. And this is already installed with sharding. Like you can see, like maybe a pause here. Too late. Okay, but you could see like there were 4 Fleet controllers running. So now you can basically choose, when you create a Git repo, you can choose one of the Fleet controllers. Currently, we still have to do it here in YAML. This was the reference to Fleet controller 1, and you can see that, I think it's, you couldn't see that. It's currently idle. So now, no, it's currently deploying example 1, right? So when I add a second one, I can just call it example 2. I tell it like deploy on shard 2. It's deploying on shard 2, and you can see like the shard 1 doesn't do any work. While if you would look at the logs for shard 2, you would see that it's now working on the deployment, and that worked too, right? So this is one way to scale well, horizontally. Looking at metrics, right? This has the Rancher monitoring installed. We are in an early stage here, but we have some Grafana dashboards, fleet controllers. At least 2/3 of them now report metrics to Prometheus. And we have some dashboards here that show you how many bundles you have. And the framework we use also exports like timing information. So in the future, we will be able to show you how much time is spent in which part of the reconciliation phase. How much time is spent on dealing with Git repos, how much time is spent on the targeting controllers and such. Right, there's sharding and metrics, and this is another thing that's more like a preview, but the fleet CLI grew a little bit, so we added 2 more subcommands. Fleet apply is old, and fleet apply is basically used to convert what you have in a folder to a bundle, so you can actually run this locally on your machine to see what would happen. And fleet target now takes the output of apply and prepares it for a cluster, and then we added fleet deploy to basically take that output and actually put it on a cluster, and that has a dry run mode, so that you can actually preview the changes before you apply them. So this is like a very simple repo with a simple fleet YAML, just downloading an external Helm charts. I'm using external secrets operator here, and I think this is optional, like a target YAML file to target specific clusters. But so running fleet apply like we would do in the controller in a job. With some commands, it will create like this external secret operator bundle, then running fleet target to turn it into a bundle deployment, and finally running fleet deploy and dry run here to get the actual preview of what would be deployed by the agent onto the cluster. And we hope to leverage this to maybe in the future, like show you a preview in the UI, right? So you wouldn't have to do this manually, but there would be a nice way in the UI to preview the changes that are actually going to end up on your downstream clusters. But yeah, that is later. So then we are going to apply to a cluster. I always typo here. Of course, this needs to be kubectl config. And selecting just like the cluster 3, right? This is called head because we are doing this on Rancher 2.9 head. Right? It's not yet released, but this is when the new features are. So we don't need a namespace. It's actually in that file, and it's basically running our Helm deployer and outputting everything it deployed. So now when we check the cluster, we see that the external secret operator is actually running. There it is. And the idea is then that you could use that in an air-gap scenario. You could use the CLI. If you had a USB stick, you could go to your server, deploy it there, and later when it comes online, then Fleet Controller should be able to adopt this installation. That is nearly it. We are nearly at the end. A little bit about the roadmap for the next years. We want to look into scheduling deployments, so you can give like a maintenance window for Fleet to do the reconciliation, or if you need to go live at a certain hour or something. We want to integrate better with external systems, like notify them of things that Fleet is doing. OCI, we started to support OCI downloads of charts, but we also want to be able to monitor OCI registries, so you would have like a more direct flow than the current one, which takes a Helm bundle, right, turns it into a bundle, and then gives it to the downstream agent. So the idea here is to just monitor an OCI registry and then like deploy what is in there. And we are asked to come up with a Fleet 1.0, so when it's well documented and all the features are there. This would be fun. Thanks.